Hello everyone, welcome to today's live webinar. Thank you for joining us today. I hope you can hear me loud and clear. I'm Michela Fassi, I'm Communication Manager at Milestone, and I'll be your moderator for today's webinar. Today we are here for our webinar titled How to Improve Specimen Handling from the OR to Archive. During this live webinar, we will discover the best practices on specimen collection and transport. Milestone has been in the field since 30 years. Our mission is to reduce patient anxiety by providing pathologists with technologies for same-day diagnostic results. Today, Milestone is proud to offer innovative solutions in 6 different fields: frozen section, cytology, sample handling, tissue processing, macrodigital, and reagents. Before we get started, I wish to inform you that Milestone organizes this type of webinars once a month, and you can follow us on our LinkedIn and Facebook pages or on our website to stay tuned. Before we start, I kindly ask your attention for a few seconds. In this slide, you can see the main functions of the WebEx platform through which we are broadcasting. Since this webinar is intended to be interactive, we encourage you to ask questions. You can submit questions anytime by typing them in the Q&A box, which is located in the right bottom part of the window. We will answer some questions at the end of the presentations, and for all questions that may not be answered live, we will reply by separate email. The slides will flow automatically during the webinar. If you have any technical problem in viewing or hearing the presentation, please write to the host in the chat box and we will try to support you. You can also notice some little icons on the right upper corner of your screen. You can use them to adjust your screen display anytime during the webinar. We suggest the full screen visualization, especially during the demo from the lab. Now let's take a quick look at today's speakers. We will first have an introduction from Marco Bellini, who is General Manager at Milestone Medical, and then Marco Perrella, Application Specialist, will carry out a live demonstration from Milestone Laboratory. This presentation today will be recorded and will last about 45 minutes. Now I think it's time to start, so Marco, I am giving you the floor.
Thank you, Michela, and thank you to all the participants to this webinar with the title How to Improve Specimen from Operating Room to the Archive. So let's see together what will be the agenda of today's for this webinar. We will discover different scenarios and try to learn the best practice on surgical specimen collection and transportation. That will be the aim of today's webinar. Then, as mentioned by Michela, we will have a practical demonstration, live demonstration from our laboratory at Milestone headquarters. I want to start, first of all, with this slide that is the histopathology cycle, where you can see that everything start and end with the patient. Why I want to start with this slide? Because we must remember that the moment the specimen leaves the patient body, the diagnostic path and therefore the treatment starts. So today in this webinar, ultimately, we are talking to deliver to the patient the best possible treatment. We will be focused in particular to the sample handling circle in this portion, where the specimen leave the team of the operating room, surgeons and nurses, and get transferred to a second team, the histology lab technicians. This important step is very critical because, as mentioned, there is the specimen that is moved from one team to another, and therefore is also the initial phase of the diagnostic path. The state of the art today for preserving the biospecimen is using 10% neutral buffer formalin. That is still the fixative use majority of the case for the histological sample preservation. This open up the first critical consideration in the specimen handling for the histological diagnosis. Well, the first consideration is the formalin, because formaldehyde has been classified since 2016 by the International Agency for Cancer Research as carcinogenic and mutagenic to humans. So formaldehyde or formalin, basically a saturated water solution of about 40% of formaldehyde is basically 100% formalin. Okay? So the reclassification of formaldehyde face the safety officer in hospitals and hospital administrations, laboratory managers, to a different way to handle it, and therefore a higher cost for operator safety and disposal. So what is necessary to do when a substance declared carcinogenic need to be handled and it is present in the environment? Well, first of all, the regulation indicates that it's necessary to try to eliminate the substance or replace it with something less and or not dangerous at all. Yes, there have been different fixative in the market for years, alternative to formaldehyde, to formalin, but no one has today replaced the use of formalin that, as mentioned before, remain the state-of-the-art fixative for the biospecimen. So in case like this one, the elimination of formalin is not possible in almost the totality of the situation, what is necessary to do? Well, in that case, if a substitution is not feasible, it's necessary to use a closed system to comply with existing occupational exposure limits. And therefore, to minimize, the goal is minimize the worker exposition to that, to reduce the level of exposure as low as possible, and constantly monitor the worker's health. So situation like this one, see in the circle, where a nurse in the nearby dirty room in the operation room center dispense pour manually the formalin from a container into plastic bucket where the biospecimen is present, are not possible anymore. Some group of pathologists or operating room nurses adopt what the so-called pre-fill formalin buckets. For pre-fill, I mean containers that arrive from the supplier, sealed with already inside typically 50% of their volume with containing 10% neutral buffer formalin. So our basically operator in this case doesn't need to dispense formalin from a larger container, simply open the lid, drop the biospecimen and close the lid. So our pre-filled formalin buckets are a good alternative to prevent exposure. Well, let me show you an interesting publication from 2016 published on Toxicology Research magazine. This was a study done on two groups of nurses from a group of hospitals in northwest of Italy, in the Piedmont region. So they asked to this group of volunteer nurses to do this research. So on routine basis, the first group of nurses handled formalin in the operating room using a formalin bucket and all pre-filled formalin containers, while the second group delivered specimen in fresh conditions, so they were not exposed to formalin in the operating room. Through two markers detected in urine analysis, the two markers basically are present in the body, and they get oxidized in presence of, in case of absorption of formaldehyde in the body. they measured the level of absorption, indeed, of formalin detected through the urine analysis. The results were quite significant. The level of formalin detected in the body of the second group of nurses, so the one that did not manipulate formalin in the OR, was 75% lower than the first group that handled formalin. So quite significant. Why not 100% lower reduction? Well, because formalin is still present in our daily life, like in clothes, furniture, food processing. So the industry use formalin during the items process. Of course, also the industry need to change the type of fixative use for. There is another critical consideration that need to be done in the biospecimen handling and collecting. The second critical aspect that I point out today is we need to strongly consider the preservation of the molecular material of the biospecimen. In these past years, the progress in precision medicine and personalized treatment required to perform additional tests in addition to the morphological evaluation, normally done by pathologists. These tests are tests like DNA, RNA, and protease extractions for gene profile expression. For these tests, it is important to maintain the tissue in perfect condition and to control the pre-analytical variables. For this reason, new guidelines have been released from pathology associations around the world, like the College of American Pathology, the European Society of Pathology. I will show in a moment a few examples. This paper, for example, published in the recently, November 2019, in the Archive of Pathology, Laboratory Medicine, was done by a larger group of pathologists, and there was a call of action, a sort of call of action to find pre-analytical recommendation for the molecular integrity of cancer patient biospecimens. I literally read from the bottom: specimen handling and documentation to ensure patient safety and accuracy of biomarker test results is crucial for the advancement of precision medicine. So there is a strong need to find standardization and a perfect way to collect the specimen. Not only the Pathologist Association, but also in this case, the American Operating Room Nurses are pointing out how the specimen management need to be performed at the collecting point. This picture has been taken by a post done by this association, the American Operating Room Nurses Association, that they will do this series of webinars on the new guidelines update for 2021, where they include this recommendation. They also stated that it's necessary, first of all, to take control of the pre-analytical variables, and to be careful and pay attention to the exposure of operating room personnel from formaldehyde fumes. We know about the content because, as Milestone, our US colleague, has been called by the association to contribute on the revision of the guideline. So, in simple, the documentation and standardization of pre-analytics variables is now a must. So, we must reduce the variables and make it a more standard procedure. To do that, data collection is fundamental to understand for pathologists when a fixation process starts. So, in addition to the case ID, obviously, that need to be tracked with the barcoding system, other data are necessary to be collected. I'll include the operator name because if the procedure is not handled correctly, we need to find a root cause analysis of that and rectify that, maybe with more training at the collecting point. Date and time of operation, as mentioned, it's essential to understand when the fixation procedure starts or the collecting procedure starts. Therefore, biospecimen and fixity weight and the ratio between biospecimen and fixity. Obviously, the specimen may have different mass and volume, and therefore formalin ratio is essential to be always equal and constant. The last important parameter to be monitored that today is not monitored is the temperature condition. Why temperature condition? Because the fixation is a chemical process. And therefore, if the chemical process happen during the transportation in winter time or in summertime outside the hospitals, you may understand that the chemical process may be influenced by the temperature condition, colder or warmer weather. With these two considerations in mind, for the specimen handling, which options today are available? Well, definitely we have the option to collect and transport the specimen in fresh condition or collect and transport the specimen in formalin. So formalin, with all the consideration we have done, but still the state-of-the-art fixity. There is a logistic implication, definitely, that need to be considered because, like in the example on the top side, if operating rooms and histology lab are within or under the same roof, within the same hospital or campus, definitely the logistic of transportation is more easier and quicker or under control compared to reference histology lab that collect the specimen from different clinics and operating rooms. In any case, the transportation in fresh or with documented information can be done, obviously, in both logistic scenario. So in case of the collection and transportation in fresh condition, a scientific validated and approved method is the utilization of vacuum bags at controlled temperature. For controlled temperature, I mean 4 degrees Celsius, so not below the zero, the freezing point. With this condition, histological specimen can be maintained up to 48 or 72 hours. The difference of 48 or 72 hours is depending by the type of tissues. The most resistant tissues, like a breast resection, for example, can last up to 72 hours. The importance is to maintain at 4 degrees Celsius the entire vacuum bag. And the vacuum, it's a good method to speed up the refrigeration of the biospecimen and the preservation from the surrounding environment. In this paper that's been released by the European Society of Pathology, they mention the guidance for laboratory performing molecular pathology for cancer patients. They indeed recommend the control of fixation time and temperature for molecular analysis of proteins. And they indicate the vacuum packing of tissue and transfer to the laboratory at 4 degrees Celsius as one recommended option. As today, we have more than 50 scientific documented papers by independent group of pathology and institute that validate the vacuum transportation and collection and storing for examination. In case there is no alternative but placing the biospecimen in formalin at the operating room, by the operating room, our strong suggestion is to use automatic formalin dispensing system that prevent operator to get exposed to the fumes during the formalin dispensing. Not only system, but also dedicated bucket. In this case, Milestone developed a dedicated bucket with the lid built-in a valve that is, you will see in a moment in a live demonstration, prevent the any leakage of liquid and the fumes. So the suggestion, strong suggestion, and the best practice, as mentioned, is to take care of the biospecimen from the very beginning, at the collecting point. Milestone developed a series of tools that, again, we will see shortly from our laboratory. You see listed here. Two of them are vacuum system, Tissue Safe Plus and the Seal Safe, that use vacuum bags. These two systems vacuum seal the specimen, with the difference that the Seal Safe, in addition to the vacuum, dispense formalin in a controlled way into the bag during the vacuuming process. The unit on the right side, the Ultra Safe, the latest development of Milestone, dispense automatically formalin in the dedicated bucket container with a valve on the lid. So the scenario now. Let's see when we have a fresh condition transportation, in this case, the utilization of vacuum bags. The tissue safe can be placed in the operating room, nearby the operating rooms, in the so-called dirty room, and it can serve several operating rooms. In this case, the tissue gets placed in the bag, transport at controlled temperature of 4 degrees Celsius, and get received to the pathologist, the pathology department, in fresh condition. A system, vacuum system like the Seal Safe, can dispense formalin in a controlled way in the bag to start the initial fixation, and or reseal the bag with the remaining of the tissue for the final archive, with major benefit in space reduction and cost disposal reduction. So this scenario represents or introduce a lot of advantages, like the standardization of the fixation parameter, no formalin at all in the operating room. We had some users that for which the hospital administration forbid the use of formalin, banned the use of formalin in the operating room. So for pathology department, there was no choice than use this type of delivery, fresh condition. The control of formalin fixation will happen in pathology department. So the pathologist will have the possibility to receive the specimen in fresh, do whatever they want to do for the molecular analysis, and control exactly and standardize exactly the formalin fixation time. Then, as mentioned, that there is a dramatic reduction in disposal cost due to the reduction in space and dumping material. We need to keep in consideration in this case that the tissue will arrive fresh, and therefore the grossing for a pathologist assistant will be done for fresh tissue, on fresh tissue. The second scenario, on the contrary, is the collection and transportation in formalin. As mentioned, a system like the UltraSafe can avoid the exposure for operating room personnel, and in this case, the transportation happens more in a traditional way, but with advantage that the UltraSafe will automatically record and provide information about the fixation parameters, starting point, and volume, all the rest. In this case, the tissue arrives partially fixed to the pathology department, and the same bucket could be used for the archive. In this case, I already mentioned some of the advantages, but again, the advantage in this case is the standardized fixation parameter. No need to revalidate the procedure if a laboratory already received the tissue in formalin. The control of fixation parameters definitely is one big step of advancement. No formalin exposure in the operating room, and the standardization of fixative ratio. In this case, the tissue arrives partially fixed in the laboratory. We have actually some users that have a mixed scenario, so fresh and fixed tissue, because it happened that for the majority of the tissue it was okay, the transportation in formalin, but for some other tissue there was the request to get store and transfer in fresh. For example, we have an American hospital that requested the tissue to be kept in vacuum bag, the placentas, for example, to be kept in vacuum bag directly in the labor and delivery department, and then only the ones that were necessary to perform the pathological examination were transferred to the pathology department, even after 2 or 3 days. The rest, they were remaining in vacuum bags and then disposed directly from the labor and delivery department. So in this scenario, nothing prevents to still use a vacuum system in the pathology department to vacuum seal the biospecimen and to get advantage of the reduction of space for the archive. On that regard, I have a couple of pictures. The one on the left side, that is a classical archive of buckets with all the storing that happened in the pathology department for the remaining of the tissue. On the right side, there is a picture taken from one user, one pathology department, that was basically the vacuum packing of the tissue during a day. And so the tissue, remaining tissue of the day were put in the plastic bin on which there is the list printed out by the machine itself with all the identification number of the cases contained in that bin for that day. In that case, the reduction calculated also in a white paper that is available on our website, we can save up to 75% in space reduction, but most important, 50%, up to 50% in disposal cost. In particular, when we consider that the disposal cost in these days rise up based on the fact that formaldehyde is carcinogenic. So now there are specialized companies that take out and dispense the media for the laboratory. So before leaving the word to the stage to my colleague Marco, the takeoff conclusion of my presentation, as mentioned at the beginning, are these two: eliminate formalin exposure for operating room and pathology laboratory personnel. Today is a must. We cannot go around it anymore. Second point, for the precision medicine molecular diagnostic advancement, the standardization and documentation in the pre-analytical step is essential. Same thing, we cannot go around anymore. Don't forget, the diagnostic process and therefore the best treatment outcome start the moment the biospecimen leaves the patient body. Thank you for your attention. I give the now stage to Marco Perrella.
Thank you, Marco and Michela, and good afternoon. Today, before we go in some further details of these three instruments I have with me here, it's really important for me to speak about the 4 principles that led the development of all these devices. So which are the safety for the specimen, safety for the user, documentation, and standardization. And these last points are the reason why on each of these instruments you do have a printer and a barcode. As first, I want to speak about tissue safe. So in order to give you a better sight, I need to change 1 second the camera angle, and so we can see it from the top. Tissue safe, it's an instrument which is has been developed mainly for fresh tissues. And since it works with bag, the first attention goes to the bag I have with me here. So here I only have 2 of the 4 available, but I have from the smaller up to the larger ones. And that gives me the occasion to just show you the broad range of specimens you can cover with all these bags. On each bag, you do have a unique barcode. On this barcode, you do have information about the bag size, how many times this bag has been used. And after a procedure, like the one I will perform in a few moments, after the procedure, I will have an association between the identification code of the bag and identification of the patient. For the sake of this demo, I do have with me already a sample inside the bag. So, and working with tissue safe, it's really intuitive and straightforward. In order to proceed, you just need to scan the identification code of the bag, the ID of the patient, the requisition form, place the bag inside the cavity, and select the intensity of vacuum. Here I will select the strongest. Simple pressure on the cover will be just enough to start the procedure. What you hear now is the air which is getting removed from the cavity. And this air is getting out through an HEPA filter. I will anticipate that at the end of the procedure, all the information of this specific procedure will be printed here with the printer I point to now. The vacuum has completed. Now the bar is sealing the edges of the bag, and the air will flow again back into the cavity. On this level here, now I do have all the information of this procedure, such as date, time, which kind of level of pressure I applied, and also the identification of the operator who has done the procedure. Of course, this I can peel it, I can open it, and stick it physically, bind those information to the specimen. Of course, these information are printed on the sticker, but they are also stored in the system. And those information can be retrieved anytime by the laboratory, the informatic laboratory, toward CSAFE. But before to do that, I want to recall you the fact that Mark mentioned also in this presentation, that in cold condition, this specimen can be maintained optimal morphology up to 72 hours. And that's why Milestone has developed the temperature data logger that can be loaded here on the side of the instrument at the end of the procedure, and then can be coupled together with the specimen. From the moment of the activation, the temperature of transportation up to the reaching point, which might be, for example, the grossing table, can be monitored. And so we have the complete traceability also of the transportation. As promised, we move now toward seal-safe. And already from its design, you can see that the same principle of tissue-safe have been maintained. However, seal-safe has the capability to couple vacuum with the possibility to dispense formalin. And now we are not speaking just dispensing formalin, but also to precisely track when the fixation has started and how much formalin did you pour into the bag. And in order to do that, that's why in the cavity here, you do have a scale to monitor the weight of the specimen and the precise amount of formalin. Since we are dealing with fluids, I want to mention the other two bags available here, which are the so-called self-standing bags. The name is self-explanatory, are bags which are designed to stand up vertically, even if they have specimen and fluid inside. Also, in this case, I have a sample already ready. And in the cavity, and in order to start the procedure, I just need to scan the identification code of the bag, the identification of the patient, and place it in the cavity. I can have these magnets which add further stability to the bag. And now I do have, instead of vacuum, I do have here on the display the ratios. What do they mean? Basically, I will select 1 to 2 for this demo. It means that for each gram of specimen, the system will dispense 2 grams of formalin. I will select 1 to 2, and I will arm the injection nozzle. As tissues adjust the pressure onto the cover, we'll start the procedure. There will be a first phase of vacuum, followed by the injection of formalin. Now, what is really important and I do care to show you is that you have the specimen weight here, and in real time you can see increasing the amount of formalin. So that's what I mean for documentation. You have all the weight of formalin here. One thing that I take advantage of this close-up is that all the cover here, and as well in the other instrument, is an antibacterial coating based on silver ion, so for user safety. Now the procedure is terminated, and the sealing is getting completed. As you can see, up to the end of the procedure, I was never in contact with formalin, because all the dispensing of formalin is taking place inside the protected environment. Now the bar is sealing the bag, and I will get a label with the information. Similarly to tissue safe, also here I do have the complete documentation, the identification of the operator, date, time, but moreover here we do have also the weight of specimen, amount of formalin, and ratio between these two. Again, I can physically bind this information on top of the bag, and now I will have my specimen under vacuum with formalin. Here, since we are already here, we do have the drawer, which is a ventilated drawer, from where you can load the reagent into the cavity. Here, the point here is that you can load any kind of commercially available tanks. Here you have a QD-tainer and a 5-liter tank. Again, this drawer is ventilated, so for user safety. We move now towards the third part of this presentation. And I need to go back to the previous camera. Once we get the principle of documentation, traceability, and safety for the previous two instruments, the same principles are made for ultrasafe. So therefore, it's really intuitive even to work with ultrasafe. Despite from the first two instruments, ultrasafe work with buckets. And speaking with buckets, here I do have the bucket available from the 1 liter up to 10-liter bucket. And all of them comes in a transparent of white version. And this range of size is are designed to cover the vast majority of samples you're going to face in your daily routine. In order to introduce you the practical part, now I will simulate as I pretend to be the operator, which receive a surgical piece in the surgery room. Now I will receive the specimen and I close the cover here. And one thing very important it's very important for me to share is that in a traditional bucket, what happens is that in order to pour formalin, the bucket, the cover has to be removed, or maybe you work without cover at all. And in that moment, you are exposed to the fume of formalin and to the potential pathogens connected, linked to the specimen. Thanks to the unique valve of ultrasafe, now the operator just closed and can walk toward the ultrasafe without need of reopening. And as you can see by the design of the valve, the specimen is completely isolated from the external world. As in the previous instrument, I need to scan one of the barcode on top of the bucket, scan the requisition form of the patient, and place on top of the scale. I will just slightly zoom to give you a better sight. I, on purpose, put it not in the center, is off center, because one of the features is that the system will automatically center the bucket. Once the door is closed, I can select the ratio. The cavity, it is ventilated, of course, and you see the auto centering, and beside the cavity, the fact that the cavity is ventilated, here you can see that there is an additional ventilation. So you have a redundancy of security measurement. Now the pump will start to inject formalin, and I wanted to mention a few other features, such as you can see that there is an LED that shows the status of the machine. Now with blue at the end will turn green to give you an immediate feedback of the status of the machine. And plus you do have UV lamp. So at the end of any procedure or at the end of the day you start automatically, you have the possibility to disinfect the cavity with UV light. The procedure is now terminated. And I get a label with all the information. Before to attach those information to the bucket, the user simply needs to take out, to close the bucket inside the cavity. And now can attach all the information. And now this sealing is airtight and watertight. Therefore, you are completely safe from formalin fuel, and you can even flip it without any risk for your health. With this part, I will conclude, and I give back the word to Michela.
Thank you, Marco and Marco, for your presentations. Let's now read some questions. I have already received some, and if you have any other question, now it's the moment to type them in the Q&A box. So Marco, in the laboratory, a question for you about ultrasafe. What happens if I put an already closed bucket in the unit? Do we risk formalin spillage?
Okay, the answer is no. Because the system, the unit is designed to work only in ideal condition. So now I will, instead of doing technical explanation, I will just simulate this case. I will place inside a closed bucket. So I scan the ID on top of the bucket, scan the requisition form, and what will happen is that the sensor in the injector, which is the part that is lowering down, will sense the resistance on top of the valve and will retract automatically. So there is no risk of any spillage or, let's say, misuse of the valve. I will get a warning message here, a message, and the user can now just take out the bucket, open it, and redo the procedure.
Okay, thank you, Marco. Another question for you about the containers that I use in UltraSafe. Can you explain better the size?
Okay, so if you mean the container like the one for specimen, those buckets, we do have buckets from 1 liter, 3 liter, 5 liter, and 10 liter, which again comes in white or transparent as the one I used for the demo. If you instead need the container for formalin inside the drawer, I need to change the camera again so I can give you a more precise view of the drawer, the ultra-safe drawer. Okay. So here, this is the ventilated drawer of ultrasafe, and the thing is, here I've loaded different sizes. So I have here a 5 liter normal tank, a 20 liter over here, a 10 liter cubitainer. So this system gives you a very large freedom of what you want to load. So you can load basically any commercially available tank up to 4 a container of 20 liters. So you have 80 liters of range. One further thing is that you do have a rapid connector here, so you just need to press and plug, and it's very easy to plug and to pull.
Thank you, Marco. Now we'll switch to the other Marco for other questions. So Marco, can Milestone units be connected to the LIS?
Yes, as mentioned before by my colleague Marco, the system generate data and collect data. I saw also another question asking if we can add information or change information that are printed on the label. Yes, I will answer right now to that question, saying yes. In addition to the information, it's possible to add other additional information to the label and to the data. And in particular, to answer to your questions, the system through the middleware of Milestone called MileWatch are able to send the information to the laboratory informatics system. Not only, but also the middleware can notify the status of operation. And in particular, for the sample that get the biospecimen that get prepared in our ultra-safe or vacuum system, the notification can be sent by email to the receiver with stating what was done in the specific moment. So, for example, the pathology department can receive, in addition to the information to the LIS, also email notifications of the amount of specimen that get produced in the several collecting points at the operation room centers.
Okay, thank you. Another question for you, Marco. Where can we find the publications that you mentioned in your presentation earlier?
We have on our website, milestonemed.com, a pretty large collection of abstracts and posters and scientific publication. So if you go on our website, there is on the top menu, the menu called Education, under which you will find a publication listed by type of instruments and applications.
One final question for you again, Marco. Is it possible to archive bags for 2 weeks without formalin?
Yes, indeed. We have users that after the primary fixation, they just with the tissue soaked with formalin, they vacuum pack the tissue in vacuum bags without adding formalin. And for actually longer than 2 weeks, we have also publication or studies done on that. Tissue can be preserved for the archiving, and therefore the advantage is that the disposing happen like a normal biohazard waste instead of decant the formalin out from the container.
Okay, thank you again for your answers. I see that time is running out, so for all questions that have not been answered live, we will reply by separate email. Let me now share this slide with our final contacts. If you have any other question left, if you wish to receive any material from us, you can contact us, please do not hesitate. And our application specialists are available to organize any virtual demonstration, to provide demonstration, consultations, or solution through face-to-face conversation with live webcams. So you could virtually enter in our lab as you've seen today. This webinar will be available for on-demand reviewing starting from tomorrow. You will receive an email message when the webinar is available for replay. If you wish to keep up to date with Milestone new live events, we suggest to check our website and follow us on our social networks. You'll find all the information about our future events. And by the way, you can save the date for next live webinar, which will be on the 2nd of December. Thank you once again for your attendance and your interest. We hope to see you all next time. Goodbye and arrivederci.